Hi, welcome back. This is Dr. Revales, and I'm going to show you how to solve this problem of separating complex gas mixtures. This is very important transformation of raw materials into finished products. This is a multi-billion dollar industry and produces billions of tons of raw materials every year. Okay, we have here the problem. We start from an inlet of 180.1 kilograms per hour. That's the inlet flow. And we have three components, ethanol, three alcohols, ethanol, isopropanol, and butanol. They are given as the compositions. And they go through these separation towers in which the initial flow is separated into this flow one, I'm going to call X1, and another flow, which is further separated into these two other flows. So the problem is, from the given information, find the unknown mass flow rates. And you can see already that we have three unknown variables. We don't know these variables, which is the flows. I call this X1, X2, and X3. So because we have three variables, we need three equations. So what I want to do is want to make a balance. And we can have different balances, but the one we're proposing to do now is this total flow balance. Okay, we know X1 plus X2 plus X3 equals F total. This is my first equation. X1 plus X2 plus X3 equals the total 180.1. And then I'm going to choose only two alcohols. That is really my choice is ethanol. If I do a balance of ethanol, you can see the X1 has a composition of 0.76 ethanol. So 0.76 ethanol plus the F4, this second X2 has 0.13 in X2 plus 111 in X3. That equals the initial ethanol. Remember, I'm doing a balance for ethanol. Initial is 0.13 times the initial amount of ethanol, of total flow. That gives me my balance for ethanol. So I have now two equations. Do one more. I'm choosing to do isopropanol and do exactly the same. How much isopropanol is coming out from X1? X1 times 0.23. That's my balance for isopropanol from this X1, plus how much is coming from X2, plus how much is coming from X3, right? Equals because it's a conservation of mass, so it has to be the same as the initial amount, which is the initial amount of this isopropanol is 0.69 of the initial amount, 180.1, have 124.263. So now I have a system of three equations with three variables. Again, we can solve this by process of elimination or by substitution. But instead of that, we want to use matrices. We want to use matrices. So I can transform this into a matrix form, which I'm going to write this way. Remember, this is exactly the same as I wrote above. So this is the matrix of the components, the coefficients, 1, 1 times X1, X2, X3 equals 180.1. So I'm changing this top three equations into the matrix form of the form A times X. X is the column of the unknown mass flow rates equals B, right? B is the inlet flow rates, right? These numbers. Okay, that's the key part. Changing from the three equations into the matrix form. To solve this problem, we need to find the inverse. Let's see what find the inverse, because the solution of this problem is given by this, right? So AX equals B. So X equals A inverse, the inverse of this matrix times B. So let's calculate that. So we calculate the inverse of this matrix. Put here. Okay, let's calculate the determinant. Just to see the determinant is of this matrix has to be different than to 0 to have a solution. Okay, that's good. It's not. The inverse of the matrix, okay, let's call inverse equals M inverse of this matrix A. Control Shift Enter. That's my inverse matrix. Okay, now I'm ready to solve the problem because remember, I'm looking for this column vector of has the X1, X2, and X3. So if I multiply the inverse of the matrix times this B vector, I have the solution. That's what I'm going to do next. So I'm going to do here. Okay, let's add them here. So this is going to be a multiplication equals math multiplication of the inverse matrix times the B vector. Give me the solutions. So that's the solution. That's the solution we are looking for, x1, x2, and x3. And just double check, if I add them up, they has to be the same as the initial. Remember, we always need to double check that our results make sense. Okay, we'll solve the first part of the problem, which is using matrix operations. What we did is three balances, total flow, ethanol and isopropanol, solve the flows. The second part is calculate the average molecular weight of the input stream using the following equation. Okay, let's make a table here. So my table is going to be grams, molar mass, mole flow, mole fraction, and I'm going to find the average molecular weight. Okay, so let's see. We know we have the three alcohols at the entrance. And the mass flow is whatever I'm getting from the beginning, right? Which is equals total, which is 180.1, times the composition, 0.13. That will give me kilograms, but because I want grams, I'm going to multiply by 1,000 to get the grams, okay? The grams, okay? So multiply, let's see, for the inlet, 180.1 kilograms times the composition of the alcohol, 0.13, times 1,000, give me the grams. Okay, I'll do the same for the other ones. So 180.1 times the composition, 0.69, 1,000. Give me this one. And for the last one, 180.1 times the composition is 0.18 times 1,000. Okay, now I have the mass flow in grams. Actually, that will be grams per hour. Let's take 1 hour. That will be the mass in grams. Mass in grams. Now you can look it up. The molar masses of ethanol is 46, isopropanol is 60, and 74. Okay, let's take a base for 1 hour. For 1 hour, how many grams? How many moles? Moles is mass over molar mass. So I can do mass over molar mass. Give me how many moles per hour. Mass over molar mass. Let's see. I want to reduce this the number of digits. And let me increase the font size. Always want larger font sizes here. Okay. Now I got the number of moles. I got total flow in grams, molar mass, but I want to add them up. If I add the total number of moles, that will be the total number of moles is this. This is total. This is the number, is the total moles. And I want to use this because to calculate the mole fraction, you remember mole fraction is moles of the species over the total number of moles. So mole fraction equals this number of moles of that particular over the total number of moles. I'm going to keep that. It's going to be a constant when I calculate for all the others. And that should add to 1, of course. That's a mole fraction. Okay, but remember what we are doing is solving for the average molecular weight of the mixture, which is this equation. Multiply the mole fraction times the molar mass to get the average molecular weight. So I'm going to multiply the mole fraction times the molar mass. Okay, and if I add these three, because you remember that each of these is this component, is mole fraction times molar mass. If I add them up, I get my final answer, which is this one. So this will be my final answer, which is average molar weight in the inlet. Grams per mole. Average weight, average molar weight, right? Okay, so follow this problem. Again, it's helpful that you use this as your reference when solving your workbook. The numbers are not exactly the same, but of course, if you follow the procedure, you should be getting the correct answer. Okay, thank you for watching, and I'll see you on the next video.